Ready?
Yeah, Jerry, we need a round of applause. I'm Jerry Tuttle. I'm an actuary and a math teacher. My students tell me math is hard and math is boring. But a lot of things in life are hard. I would guess putting on...
I'll take Jerry's shot.
Putting on highlights. I've done a lot of that. As far as the boring part, I decided what my classes need are original cartoons. So I hired a cartoonist. It's been a lot of fun communicating with a cartoonist. Here I scare my algebra class with the rest of the document. Here I illustrate a statement and its converse, not necessarily both true. My friend Mary puts on lipstick only right before a date, but my female students need to know that the converse is not necessarily true. What can you do with trig functions if you're not going to be a surveyor? Because of the cyclical nature of trig functions, there's a potential use in biowords. So here I'm telling her that her best day is going to be the 6th. Pi appears in virtually all of my math classes, and I like to tell my students that you can approximate pi from the Bible. It's 1 Kings 7:23 and 7:26, and to do that, I measured my cubit, and I measured my hand breadth, and you get a pretty good approximation. Students struggle with transformations of functions, and a transform function is part of a family of functions. So here this young lady has transformed herself every 15 minutes, but these are basically the same function. Rene Descartes walks into a bar. The bartender says, "Would you like a beer?" Descartes says, "I think not." Plus, it disappears. Here, this is Descartes' rule of signs, and notice that I'm stepping in both the positive and the negative roots. An infinite number of math teachers walk into a bar. The first person says, "I'll have a beer." The second person says, "I'll have half what he's having." The third person says, "I'll have half what he's having." The bartender pours 2 beers and says, "They should take care of everybody." Here's the lottery girl. She's already drawn 3 nines, and she's about to draw the 4th 9. People seem to think that's an unusual pick of numbers, but of course that's no less likely than any other number. Standard deviation is an unfamiliar topic to a lot of students, and I think it helps to show an example of 2 data sets with the same mean but different standard deviations. And these are baseball and football players with the same mean. Here's a graph of 16 years of sales data, and that year 16 looks pretty different. There's some reason why? Well, there's generally a reason why there's an outlier, and this one's pretty clear. This is a Poisson problem. I'm telling people that on average, I see 0.3 bears a day, and I ask what's the probability of seeing 1 bear tomorrow. And by golly, my artist drew me 0.3 of a bear. This is the smart aleck question, answer that I would give to the question, how high do you want the door? I want it high enough so 95% of adult males will fit in it. And I do that with a normal curve. This is one of my rare uses of color. In fact, I'm color challenged. But between when to use the Z distribution and when to use the T distribution, I'm pleased that I colored the curves and I colored the sweatshirts. And my students seem to enjoy that. Here's a margin of error problem where the chance of him catching the ball is related to where on the normal curve in his baseball glove the ball falls. Here's a hypothesis testing problem. I've poured a number of glasses of what should be 12 ounces of soda, and they all seem to be a little light. And so the question is this significant? And is the soda company ripping me off? Here I have a population of mostly blue little people on the left with a few reds, but I draw my sample, and it looks like it's a sample of mostly reds with a few blues. So the question is, did I really draw from that original population, or did I draw from the second one? And where's my sound? I am the entertainer. I've come to do my show. You've heard my latest record. It's been on the radio. It took me years to write it. They're the best years of my life. It's a beautiful song, but I ran too long. If you're going to have a hit, you got to make it fit. So they cut that 305.
Yeah, Jerry!
That's not what I expected. This is a 2-sample problem. The question is, are these independent samples or are they dependent samples of people talking? Finally, this is not my girlfriend trying to squeeze into the size 1 dress. But by the chi-square goodness of fit test, her actual distribution is not fit into her expected. So if you like the idea of cartoons, I encourage you to go out and find a cartoonist. It's a lot of fun to work with them, and the students love it. Thank you.